something totally random because they don't want to do input filtering and they don't want a collision with the inputs people do, right? Which happens. Um, that's why it's not easy to kind of come up with a generic statement. But overall, Ajax app make this, because people are no longer, maybe they still have the same old cross-site scripting filters on their app. They're using the same ones that they wrote before. It opens up cross-site scripting once again for you. Often, if a cross-site script that comes down, maybe you're not able to break out of whether the serialization is. Maybe they don't allow you to put quotes in. Maybe they don't allow you to put brackets in because they've seen this talk and they're like, oh, well, I know I'm using JSON and I know what's dangerous in JSON, right? Brackets are dangerous in JSON and quotes are dangerous in JSON, so I'm going to disallow them and I'm going to do input filtering. But I don't care about the less than and greater than symbol because those don't do anything anymore. Well, all of the stuff that gets sent down in an array to change a GUI has to get written to the GUI's DOM at some point, right? And this is where it gets a little complicated. This is a very simplistic situation where I'm doing a document.write to modify the DOM and make the page change. But if you can inject script elements, you can inject script that gets injected as child elements for different parts of the DOM. There's lots of different ways that you can get into a payload that perhaps it doesn't get attacked immediately upon deserialization from the server, but later in a delayed situation when that actually gets written into and the DHTML updated, then it actually, your trap springs. Cross-site scripting could already be in the DOM too. And this is, you don't have to actually, this is a situation like if I want an Ajax app that has some pretty complicated script that reads from things like document.location to pre-fill some fields, that I can get a referred cross-site scripting bug is because I can send you an URL that then controls document.location, or I can control document.refer. But sometimes Ajax, so I'm sorry, is there any questions on kind of the basic ways of JavaScript getting sent down or either getting written in later? So Ajax apps actually introduce a whole nother kind of cross-site scripting, which is the good old traditional kind, but something that's not expected, which is cross-site scripting outside of the context of the actual app, right? So let's say we have a situation where an Ajax application takes a get and gives you back a script, right? Our same old application. Let's say it's webmail.com. Webmail.com likes to take get requests and give you JavaScript or JSON arrays or some kind of weirdly formatted thing. It really doesn't matter what it is, right? And so I, as an attacker, open up an account at webmail.com. I send myself an email with script in it to see how it's formatted. I read my email, and while I read my email, I'm watching, because this is a cool new Ajax site, right? And when I read my email, it doesn't change the URL up top. But I'm watching in WebScarab, and I see that there's a request that goes out to my mail / getNewMessages.aspx. Obviously, it's running on a Java server. And the attacker sends, wow, that joke fell really flat. So as an attacker, I'm able to do this multiple times, and I figure out what the framing looks like, and what kind of input filtering happens, and what kind of characters I can get in without them getting escaped. And then I decide, I figure it out, and then I send the same email to my victim. And the victim gets it, and maybe he opens it up and says, wow, what is this junk? I don't know what this is. Because maybe they've seen this talk, and they're actually, I'm sending down script tags, but somewhere they're properly, when they send it down the JSON array, the JavaScript, they're not doing a full eval, or they're checking through it for something dangerous, or there's a lot of little tricks you can do with client-side JavaScript to kind of protect against attacks like script and JSON. They're doing some of those things, and he just sees a bunch of garbage, right? It doesn't actually work within the webmail interface. So I now send that victim a link that I want them to click on. That's at webmail.com, and that's the URL. And it's not the URL that you're supposed to go to when you go in the browser to make webmail.com work. It's the URL that webmail.com goes to behind your back to get the messages. You guys understand the difference? Because that's important. This is an URL that's not supposed to ever be exposed to a normal browser. And so the URL comes down, and it comes down with this code. It's JavaScript code, and I wasn't able to get this to work within webmail.com, but now I get a bunch of code that comes down, no HTML tag, no head tag, nothing like that, and it comes down and it loads in the browser. What do you guys think happens when this comes down to the browser? Obviously, the red stuff is controlled by me. Well, it turns out it's kind of determined on a lot of things. It determines on what the content type is in the HTML header, and it's determined on which browser you're running on. I can give you a guess which commercial browser likes to automatically figure out its content type for you. and it will automatically go through and it looks at this and it says var message array. It doesn't recognize this as JavaScript because there's no script tags, right? So it just says this is text. This is just text in my, and it prints this out on the screen. And it keeps on going until it sees this script tag. The script tag that meant nothing in the context for the webmail because it was in these double quotes before, right? And I wasn't able to break out of the double quotes. But now it's not in the context of the webmail reading it. It's in the context of the browser seeing this and nothing else. And it says, oh, thank God, it's my first HTML tag. I need to start a script element. And so it runs the script inside of it. So now you're thinking, why do I care, right? This isn't running within the webmail application itself, but it is, right? Because I sent a link to a person using their webmail. They are guaranteed to have a webmail cookie. When they click on it, they go to here, it's running, it thinks, in the context of webmail. It can do whatever it wants. It can steal a cookie. It can access webmail as the user. It can do whatever it wants, even though it's not running within the app itself. It's an attack against the browser with a referred cross-site scripting, right? I generally have to send somebody a link that they have to click on. It's not stored, but it's kind of stored too. So it's kind of a weird hybrid attack that actually you see a lot. Because, you know, even if you can't, this is a good backup if you can't get a cross-site scripting attack to work within an Ajax app. I lost my first person. Goodbye, sir. Have a nice day. So, I'm sorry. No. They're not reading my email. I sent them the same link. Yes, exactly. No, I sent them 2 emails, right. I'm sorry, I came up with this big hypothetical where I'm a stupid attacker and I want to try things out, right. And I tried the attack first and it didn't work, and now, so I sent it to myself to see how it worked, and then just sent them a link to their mailbox. And this is assuming that the get link doesn't have something unguessable, like a GUID that represents. So it's not for like just getting the message, but maybe if you get the entire inbox, that's probably a request that doesn't have anything that's specific for the message. I'm sorry, miss? It will think that script is running because this script comes down from webmail.com. I never said Gmail. I don't know who you're talking about, Gmail. This comes from webmail.com, which probably belongs to somebody, but somebody with less lawyers than the people that own Gmail. So, no, it thinks because this comes from it, the browser doesn't know that it was never meant to see this URL, right? It doesn't know that this URL was only supposed to be accessed by the XML HTTP request object. So it comes down from webmail.com, and so it can read the cookies. Right. They click on it, and they go to a new page. I'm sorry? So they will look at this, right? This is code that webmail.com's client-side code was originally supposed to run this, and you can see I don't have any double quotes in here. Maybe they know about these kinds of attacks, and so they're filtering out double quotes. And so if they actually look at it in webmail.com, it's very possible they're just going to see this script, written out as script. The point is, if they then just go to the URL itself, instead of the URL being pulled down by XML HTTP object, then the script runs and grabs their cookie. So, and I'm guaranteed that they have a good cookie because the only way they could have clicked on that link is if they were logged into their webmail. And I can explain that offline too later. So cross-site scripting has gotten a lot of press from MySpace. And it's interesting because the MySpace worms, the cross-site scripting bugs are just normal cross-site scripting bugs, right? It's the kind of cross-site scripting bug that you would get that, say, if your entire business model was 13-year-olds are allowed to write HTML, and I'm going to determine what HTML is or isn't allowable, but I want them to be able to do things like upload MP3s and movies and JavaScript-enabled Flash picture frames and all this kind of crap that you see on MySpace pages, which are now a supported part of the community. To say you're allowed to do that stuff and then to create a blacklist of the things that are actually evil is a little difficult, right? And so they just have standard good old, there's number 2, standard good old cross-site scripting bugs. I was hoping that I would intimidate people not to walk out anymore by pointing them out, but standard good old cross-site scripting bugs. And so those aren't actually that interesting. What is interesting is what people are doing with them. And this is a thing called the Sammy worm. Anybody remember this thing? Anybody become Sammy's friend unintentionally? Right, and so this is called the Sammy worm. He just loaded this in with a good old cross-site scripting bug. And the only thing that's really interesting here is not that he was able to get it in, it's that he's using all these Web 2.0 technologies, like asynchronous XML HTTP requests, to do something dangerous. And I've highlighted a little thing in red that says, you know, he does an initial request and then he parses it, and he looks for a thing called the hash code. Why do you think MySpace has a hash code? Well, they have it because of, look at the segue, cross-site request forgery, also known as cross-site reference forgery. This is another acronym that's going to get fought over. It can be abbreviated XSRF or CSRF, but I'm going to call it XSRF, and hopefully we can try to make the standard. We can all agree in this room to use cross-site request forgery and XSRF, and that will be the end of it, because everybody in here is all the most influential people in web application security, right? Yeah. So anyway, it's really kind of the new hotness in web security. If you haven't heard about it 4 or 5 times in the last 6 months, you're not reading enough. Why is it the new hotness? Because it is an attack that, like cross-site scripting, allows you to authenticate, to interact with the site as an authenticated victim. And it allows you, like parameter tampering, just to ask for something to happen. But in this case, you're probably not even asking for something that's disallowed by the business logic. Annalie, you can sit up here. Hi. And it's very poorly understood, so it's everywhere. Literally, almost every single web application we look at professionally has XSRF. That doesn't mean it's always really something you care about, right? Because there's only some situations in which XSRF is really important. But it is a problem if A, your site does something, if B, your application is actually popular enough to attack, because generally XSRF attacks are probabilistic, they're not aimed at one person. And C, if your users tend to have cookies. If you have an application where a lot of my users have cookies at 1:30 p.m., right? That's the kind of, if those kinds of things are true, then this is a big deal. And you can read an excellent paper, that was a very early paper on XSRF. He calls it cross-site reference forgery, but he's going to change that soon, by Jesse Burns, who's sitting right up here. An excellent paper, you can get a lot more detail on it. So what does XSRF allow? Well, the best way to tell this is to tell a true story, a true, really bedtime nightmare story about a man who was a little foolish in his web browsing techniques. So there's a nice little victim, and the victim's a yuppie, and because he's a yuppie, he likes yuppie porn, and the best, most addictive type of yuppie porn is that little ticker in the bottom right corner of your screen that tells you what your net worth is, right? And all of the different stockbrokers, online stockbrokers just have this ticker, because during the 90s is what everybody did during work was actually just watch what their net worth was, right? That ticker is often a Java application. It's a Java applet running in a iExplore.exe window or a Firefox.com window, but in a full HTTP browser window, and it generally has a cookie because it has to be able to ask the servers, give me my portfolio, and obviously you want that authenticated, right, to give somebody their portfolio. So the victim is browsing the web, and he's got his stock ticker going, and he's looking for inside information, so that he can make more money, and his little stock ticker goes up. And so he goes to finance.yahoo.com, and he reads a message saying that somebody has some leaked news, and he clicks on a tiny URL. Never click on a tiny URL. It's either goatc or it's a cross-site request forgery attack. I don't think they point at anything else. And he clicks on the URL, and he gets redirected to a page called cybervillains.com/news, which he finds like kind of an odd for a financial news site. But he's looking for inside information, so maybe that's okay. So he saves a minute he just sits there and reads a story, and then he gets bored and he closes his browser. Okay, doesn't sound like anything happens. Well, a couple weeks later, he gets his monthly statement and $5,000 is missing. Like I said, this is a true story. Now, the kind of lie part about it is that both the victim and the attacker worked for us, and we are paid to do this, but we've actually done this multiple times, and this is a great way to steal money from people. And if somebody figures out, hopefully not because of this talk, a good way to do this across multiple people, they might be able to steal a lot of money in a short period of time. What happened? So what happened while that victim was reading the story? The story page that came down that he was reading actually had a lot of script in it, and it also had 5 iframes.